So guys, whenever we are writing a reaction, of course, it may be your organic, when I'm considering most probably the organic or inorganic, no matters. We know one important thing, what is that? That a reaction is always be formed by mutual breaking of the bond, simultaneously formation of the bond. Is that true? ಅಲ್ವಾ? ಯಾವುದೋ ಒಂದು ಎರಡು ರಿಯಾಕ್ಟೆಂಟ್ ನ ತಗೊಂಡಿದ್ರೆ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಕೊಡ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಯಾವುದೋ ಒಂದು ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಿದೆ, ಆ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಿದ್ದ ಜಾಗದಲ್ಲಿ ಇನ್ನೊಂದು ಆಟಮ್ ಅಥವಾ ಮಾಲಿಕ್ಯೂಲ್ ಬಂದು ಕೂತಿದೆ. ದಿಸ್ ಇಸ್ ಅ ಜನರಲ್ ಥಿಂಗ್. But when we are dealing with respect to the chemical aspect or chemistry aspect, we say, and when we are seeing that path, that which bond is broken, which bond is formed. So that is called as what? The path now study ಮಾಡ್ತೀವಲ್ಲ, that is called as your mechanism. What it is called as mechanism. So in our today's video, we are going to see two such mechanism, one of the most important and the interesting mechanism which we are going to study when we were dealing with that of your nucleophilic substitution reaction. Mainly I am concentrating about that mechanism with aqueous NaOH and KOH. So what type of a bond is being broken over there? What type of a new bond is formed? How it is formed? And finally how we are getting an alcohol. So all that steps will be analyzed in this video. So in our today's video, we are going to learn the two important mechanism which is called as SN1 mechanism and SN2 mechanism. Yes. So basically, before giving the full form of this SN1 mechanism, let me directly dive into the reaction. Then from your words itself, let us extract the full form of your SN1 mechanism. So guys, what we know when we were dealing with that of your nucleophilic substitution reaction, yes, we came to know one important thing. And what was that? So whenever our alkyl halide is treated with that of your aqueous KOH or NaOH, I repeat, aqueous KOH or NaOH, we saw that our alkyl halide was getting converted to that of their respective alcohol. So in simple words, what was happening over there? Halide ion was moving out, hydroxide ion was coming and forming a bond with our carbon. So when I'm talking about this SN1 mechanism, generally I will give you an example over here. For example, I am taking here tertiary butyl bromide, CH3, 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 Br. Yes, what is this? A tertiary butyl bromide. So when I am treating this with, remember, aqueous KOH, so what I am getting, of course, I would be writing it as what? CH3, CH3, CH3OH plus KBr. Of course, the product whatever I obtained is what? Your tertiary butanol, alwa, tertiary butyl alcohol. Common name, I'm just saying. Yes or no? So this was a direct reaction, alwa. One reaction nodde yaro helidru, aduna nanu iduna barde. So when I want to study that, how it is taking place, that is through our kinetic experiment. So in chemical kinetics we have seen ಯಾವ ತರ ಒಂದೊಂದು step, for example, whenever a reaction is taking place and more than one step, such reactions are called as what? Complex reactions. So when we are studying its individual steps, and we saw through experimental practicals, we came to know that this step or this reaction has been divided into two important steps. So now let us deal its mechanism. Its mechanism. What does your mechanism will be? ಯಾವ ತರ ಈ ರಿಯಾಕ್ಟೆಂಟ್ ಈ ಪ್ರಾಡಕ್ಟ್ ಕೊಡಕ್ಕೆ ಯಾವ ಒಂದು ಪಾತ್ ನ ಫಾಲೋ ಮಾಡುತ್ತೆ. So that path itself is called as what? Your mechanism. So let us go with this step 1. Yes. So when I'm talking about the step 1, what is the main important thing we are having? Yes, I am having my reactant CH3, 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 Br. So first step ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ basically, of course, this is taking place in an aqueous medium. So in the first step, it involves the formation of our carbocation. What it is happening? Formation of the respective carbocation. So first it is getting ionized, and also this step is in the equilibrium condition. So what I would be getting here, I would be getting is a CH3, CH3, CH3 plus. So this is my first step where it is forming the first carbocation plus Br minus. Then I am coming with the second step. So when I am coming with the second step, what will be happening? Whatever the carbocation I am having, yes, now it will be get attacked by that of your nucleophile of OH minus. So I will be saying my second step to be attack of nucleophile. Attack of nucleophile. So what will happen now, since remember all the carbocations are sp2 hybridized, so they are in the plane itself. On the plane alli ee structure irutte. So ಈಗ ಏನಾಗುತ್ತೆ, the OH minus, which is a nucleophile, yes, it is having a negative sign, it will attack your carbocation to give us our final product, which is your tertiary butyl alcohol. So what we came to know from this reaction? So whenever we are talking or we are taking the tertiary butyl halides or tertiary alkyl halides, in simple words if I want to say, and they have been undergoing your nucleophilic substitution reaction, we are coming to know that it is following the 2 steps, in which the first step involves the formation of carbocation. That is, the CBr bond is breaking in order to give you the what? A tertiary carbocation. Yes. Then what is happening? Whatever the tertiary carbocation which has been formed, it will be now attacked with your hydroxide ion, aqueous potassium hydroxide or sodium hydroxide, whatever you have taken. In that scenario, in that compound, whatever the OH group is present, it will be acting as a nucleophile. Since our carbocation being a positively charged, OH minus will quickly come and attack our nucleophile. Of course, now when we have got these steps, now we will be seeing its kinetics, which will be at a slowest rate, which will be at the fastest rate. So when I have determined the rate, I am observing what? The first step is the slowest step, whereas the second step is the fast step. Now can you please guide me among these 2 steps, among the above 2 steps, among the above 2 steps, which is our rate determining step? Please, which is our rate determining step? Can you please guide me? Of course, alva, the rate determining step is which one? The reaction which is occurring at a very slow rate. Alva, yava reaction ige ati kammi slowest rate irutto, that will be our rate determining step. Why? Because that rate step ಆದ್ಮೇಲೆ ನಮಗೆ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಸಿಗ್ತಾ ಉಂಟು. ಸೊ ಓವರ್ ಆಲ್ ದಟ್ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಇಸ್ ಡಿಪೆಂಡೆಂಟ್ ಆನ್ ವಿಚ್ ರಿಯಾಕ್ಷನ್? This reaction. It was similar to, as I have given you an example. You have been in a reality show and you have been given in a task. You are a 4 team. One team contains 4 members. So you have been given with a race, such a race that there will be many hurdles, and you have to come, all the 4 members have to come to a final point, and at that moment I am going to stop my stop clock. So first team only 4 members. In that 4 members, individually they have to run. So first fellow have went, okay. second fellow also came, third fellow also came, but also now the stop clock is running. Why? Because the task is when it will be completed when all the 4 members are in their final point. So you are waiting for the 4th fellow to come, but he has not come. So when this fellow will come, what happens? The stop clock will stop. So all the 3 members or all the final point or the task was completed when the 4th fellow reached your final point. That is the same way we have to consider it. When will the product will be obtained? Only when the slowest step has been completed. So that is the reason it is called as what? Rate determining step. So when I am observing for my SN1 mechanism, I have seen that the formation of the carbocation is occurring at the slowest rate. So now your step 1 will be the rate determining step. So when I am writing the rate expression, how can I write? I know that rate is directly proportional to the concentration of the reactants which are present in the rate determining step. Alva. So now when I am considering over here in the slowest rate, when compared to the first reaction, I know that I have used 2 reactants. Yes, but in the slowest step, it is only dependent on 1 reactant. So I can write my rate expression as what? Rate is equals to some K times, which is your rate constant, into the concentration of our CH3C Br. Yes or no? So to the power of 1. It is independent of the concentration of your hydroxide. Why? Because it is occurring in the fast step. Rate determining step reactant yavudu, it is only dependent upon your alkyl halide. That is also tertiary butyl bromide. Now can you please say the name of this reaction? Why I have said as a SN1 for this reaction? Yes, you can easily say now. Why? Because remember, since whatever the reaction is occurring, what it is? Nucleophilic substitution reaction. Yes, of course. That nucleophilic substitution reaction is following which order? What is the order of the reaction? First order reaction. So what is the full form of now SN1 mechanism? Yes, substitution nucleophilic first order reaction. I repeat, substitution nucleophilic first order reaction. That is the reason I have not said at the initial itself, because I wanted to just extract from your words. So when we are seeing the rate expression, what we are saying is the rate expression, it only depends upon the first power of the concentration of only of your alkyl halide. That is also tertiary butyl bromide. That is the reason we say as what? It follows a substitution nucleophilic first order reaction. Is that clear? No doubts, I hope. So do remember, this SN1 or SN2 is a one sure question, 100% question in your board exam. Though I have written just the reaction, but what you have to do whenever you are explaining this formation of the carbocation, first you have to write in sentence and then you have to give your reaction. Similarly, attack of nucleophile, write in the sentence and then you have to give your what? The final reaction. Is that okay? Now the question arises to us. Okay, sir, you said that alkyl halide, but why did you choose your tertiary butyl bromide and not that of your primary halide or a secondary halide? Alva, this is a general question we can assume from you. Do remember, guys, so basically when I am talking about the SN1 mechanism, I came to know that it is following a two-step reaction. And in that also majorly the step 1 is forming a carbocation. So now when the question arises that if I am having an examples in this way, CH3C Br, then afterwards I'm having as CH3 twice CH Br, and I'm also having CH3 CH2 Br. So these are my question. I'm just giving you one question. So now I'm just asking you. So if you have been given with these three alkyl halides, in which first one is your tertiary, secondary, last one is your primary. My question is that among the three, which one will be taking place, or whose reactivity will be more towards the SN1 reaction? I'm repeating my question. Among these three compounds, or among these three different alkyl halides, whose reactivity will be faster towards the SN1 mechanism? SN1 mechanism. Yes? Any answer? I'm waiting for your answer. If you say tertiary, I will ask why. Do remember guys, if you have said tertiary, well and good. Why? Because, so when we are considering this alkyl halides and when it is undergoing an SN1 mechanism, we know that it has to get split into two steps. True? So step 1 includes what? The formation of a respective carbocation. And we know as what? When we are studying the stability of the carbocation, which is more stable among the three carbocations? Your tertiary carbocation. Why? Because they are having the three donor groups, so they can easily neutralize this positive charge on the carbon. Okay. So that is the funda over here. So now when you are talking about these three types of the carbocation, the order of reactivity ಯಾವುದು ಬೇಗ ಆಗುತ್ತೆ? First is our tertiary. It will be first undergoing your SN1. After tertiary, we are having our secondary. And the final will be our primary respective alkyl halides. And do remember, after this primary, we will be having our CH3X part. Okay, CH3X. Why is it so? Because greater the stability of the carbocation formed during the ionization in the step 1, faster will be the rate of the reaction. ಅಲ್ವಾ? ಅವತ್ತೇ ಹೇಳಿದ್ದೆ ನಾನು, ಯಾವುದೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ಮಾಡ್ತಾ ಇದ್ದಾವೆ ಅಂದಾಗ ಅದ್ರಲ್ಲಿ ಒಂದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ. ಎಸ್. ಸೊ ಆ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪ್ರಾಡಕ್ಟ್ ಎಷ್ಟು ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೋ ಅಷ್ಟು ಬೇಗ ನಮ್ಗೆ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ. ಇಲ್ಲಿ ನಮ್ಮ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಯಾವ್ದೀಗ? ನಮ್ಮ ಕಾರ್ಬೋಕ್ಯಾಟನ್. ಸಿನ್ಸ್ ದ ಫಾರ್ಮ್ಡ್ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಟರ್ಷರಿ ಆದಾಗ ಏನಾಗಿರುತ್ತೆ? ತುಂಬಾನೇ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ಅದರದ್ದು ಸ್ಟೆಬಿಲಿಟಿ ಹಿಡ್ಕೊಂಡು ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ನಮ್ಮ ರಿಯಾಕ್ಷನ್ ಲಾಸ್ಟ್ ಪ್ರಾಡಕ್ಟ್ ಏನಾಗುತ್ತೆ? ಬೇಗನೆ ಸಿಕ್ಬಿಡುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ದ ರೀಸನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್. ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಟಿವಿಟಿ ವಿಲ್ ಬಿ ಫಸ್ಟ್ ವಿಲ್ ಬಿ ಯೋರ್ ಟರ್ಷರಿ, then will be your secondary, then will be your primary, and finally will be your methyl halides. Is that clear? Okay. Now just let us share some additional information. So for example, now you have been given with your allylic and your benzylic halides. So now we are just going with some additional information. So you have been given with now allylic and your benzylic halides. Of course, you have to remember that, guys, this allylic and your benzylic halides, they also follows your SN1 mechanism. So what I am saying, your allylic and your benzylic halides, both are the primary halides, alva. So allylic and your benzylic halides, though when I am writing their structure, how can I write allylic anta baribeku andre? Please guide me. CH2 double bond CH single bond CH2 Cl. Yes. Similarly, when I am writing for your benzylic halides, how can I write? In this way. Alva. I will be getting as what? CH2 Cl. So though we can see that whatever our halogen is bonded to this carbon is what both are your primary alkyl halides. ಅಲ್ವಾ? ನಾವು ನೋಡಿದ್ವಿ ಟರ್ಷರಿ ಆಲ್ಕಿಲ್ ಹಲೈಡ್ಸ್ ಮಾತ್ರ ಫಸ್ಟ್ ಆಗುತ್ತೆ. ಬಟ್ ಇಲ್ಲೇನಾಗ್ತಾ ಉಂಟು, ಬೋತ್ ಯುವರ್ ಅಲಿಲಿಕ್ ಅಂಡ್ ಯುವರ್ ಬೆನ್ಸಿಲಿಕ್ ಹಲೈಡ್ಸ್ ಆರ್ ವಾಟ್? ದೇ ಆರ್ ಪ್ರೈಮರಿ ಹಲೈಡ್ಸ್. ಬಟ್ ಆಲ್ಸೋ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದೇ ವಿಲ್ ಬಿ ಫಾಲೋಯಿಂಗ್ ಅವರ್ SN1 mechanism itself. You can ask me, why sir? Do remember guys, because the main reason is whatever the carbocation they are forming, they are resonance stabilized. They are resonance stabilized. ಆ ಒಂದು ರೀಸನ್ ಇಂದನೇ ಏನಾಗ್ತಾ ಉಂಟು, our both allylic and our benzylic halides are also following our SN1 mechanism. Is that clear? Coming with respect to certain problems, if you have been given with a different structures and you have to arrange them in the order of their reactivity, in this case I want to just go with certain problems over here. We go with the first one. So in case now you are having the structures in this way, let me choose first structure in this way, CH2Cl, yes, and the one more structure I will be choosing in this way, CHCl. Now the question is, among these two, which will be having the higher order of reactivity towards that of your SN1 mechanism? I am very much particular about the mechanism, what I am saying. I am following what SN1 mechanism, but you have been given with the two structures over here, and the question is what? Among these two, which one will be having the higher order of the reactivity? So in order to remember this, take a note over here. What is that? Do remember, as the phenyl groups increases on the carbon containing what? Positive charge, what happens? The stability of the carbocation also increases. Yak ಹೇಳ್ತಿದ್ದೀನಿ ಆ ತರ ಅಂದ್ರೆ, what we know, of course they are following what? SN1 mechanism ಅಲ್ವಾ. SN1 ಅಂದ್ಕೊಳ್ಳಿ ಏನಾಗುತ್ತೆ, ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಸ್ಲೋಯೆಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಫಾರ್ಮ್ ಆಗ್ಲೇಬೇಕು. ಫಸ್ಟ್ ಒನ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. ಫಸ್ಟ್ ಒನ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಏನಾಯ್ತು, ಎಸ್, ಸೊ ನಾವು ದಿಸ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ವಾಟ್? CH2 ಪ್ಲಸ್. ನೆಕ್ಸ್ಟ್ ಏನ್ ಬರುತ್ತೆ, ಈ ಸ್ಟ್ರಕ್ಚರ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಆದ್ಕೊಳ್ಳೆ ಅಯನೈಸೇಷನ್ ಆದ್ಕೊಳ್ಳೆ ಐ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಆಸ್ ವಾಟ್? CH ಪ್ಲಸ್. ಎಸ್, so now what we have to remember, here we are having just one phenyl group. Here we are having what? Two phenyl groups. Alva. Since whatever the carbocation which is having these phenyl groups, basically these phenyl groups are stabilizing the respective carbocation through their resonance. Since here just we are having one phenyl group, this will be having somewhat less stable when compared to the carbocation which is having two phenyl groups, because they are much more resonance stabilized. So when the question arises in this way, you have to judge that, okay, what is the number of the phenyl groups which are present? And do remember, I am talking about the SN1. That one you have to be very much particular. So when I am writing their order of reactivity, how can I write? Which one will be the least? This one will be your least, alva. This is your benzyl carbocation, CH2 plus, which will be least. Highest will be which one? Which you are having the two phenyl groups. Two phenyl groups. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? So as the number of the phenyl group increases, what happens? Your carbocation gets more stable. Higher the stability of the carbocation, what happens? Faster will be the rate of the reaction. So this was one type of an example where I was dealing with that of your phenyl groups, number of your phenyl groups. Now when the question is in this way, I am having like this one structure. Let me take in this way. I am having CH3, one structure, and over here as a Cl, and I am having another structure is somewhat in this way. Yeah. So now can you please guide me? Which one will be having the higher order of reactivity? Yes. Very good. What is that? It is mainly your second one. Why? Do remember guys. Here your methyl group whatever is there, it is also will be going to stabilize your carbocation by plus I effect alva. Methyl group in marta untu, it is also going to stabilize the respective carbocation after ionization through its plus inductive effect, whereas the phenyl group is also stabilizing the carbocation through its resonance effect. But when we are comparing both two things, one thing we have to keep in our mind, resonance effect stabilization will be more compared to that of your inductive effect. Idu napcard itkunakagala andre one napcard itkoli. Number of the phenyl groups ಜಾಸ್ತಿ ಆದಾಗ ಏನಾಗುತ್ತೆ, stability increase ಆಗುತ್ತೆ. ಯಾಕೆ increase ಆಗುತ್ತೆ? Because they will be much more resonance stabilized. So when I am talking about these two structures, what you can say about the order of reactivity? Yes, in which the methyl group is there, that will be somewhat stable compared to the carbocation, which will be having the two phenyl groups. Now in case if I'm giving you certain 2 to 4 structures, for example, I'm giving you this structure in this way. Let me take the example CH3 Cl, and one more structure, benzene ring is over here, one structure. Let me give another structure in somewhat in this way, CH3 Cl. Yes, one more structure I would be giving in this way, CH2 Cl, and one more structure let me give you, yes, in this way. CHCl. Very good. I think everything is tetravalent. Okay. So this is my question. This is my one more question. I have given you question third. So I am having now 4 structures. Of course, these 2 structures are having the two phenyl rings. These 2 structures are having one phenyl ring. So one thing will be coming to our brain. What is that? Okay, you will do stability ಜಾಸ್ತಿ ಇರುತ್ತೆ when compared to these 2. So now within the 2 phenyl rings, I have to judge that which will be more stable. Alva, I have said you many times, whenever we are having a carbocation, we always see that what will be the number of their electron donating groups, or how much more stable they will be. Alva, ಯಾವ ತರ ಗ್ರೂಪ್ ಉಂಟು ಅದನ್ನು ಎಷ್ಟು ಬೇಗ ಅದು ಸ್ಟೇಬಲ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದು. So ಈ ಸ್ಟ್ರಕ್ಚರ್ ನ ನೋಡಿದಾಗ ಏನ್ ಕಾಣ್ತಾ ಉಂಟು, okay, along with the 2 phenyl groups which is resonantly stabilizing your carbocation, another group is your hydrogen, which is not so much important, alva. Coming to the another part, okay, it is having the 2 phenyl groups making the carbocation stable through its resonance effect, and also we are having another group, electron donating group of your methyl, which is also going to stabilize the carbocation after ionization through its plus I effect. So when we are comparing these 2, which one will be the highest? Of course, the one which is having the 2 phenyl rings and also one methyl group. So one I will be writing in this way. So this is my first structure, which will be more reactive towards that of your SN1 mechanism. So of course after this, the second 2 phenyl groups are there alva. You will to compare madre idu ಜಾಸ್ತಿ ಇದ್ದೇ ಇರುತ್ತೆ. So next structure will be this way, CHCl. Alva, very good. So now I have to judge with this one too. So ಇದನ್ನ ಜಡ್ಜ್ ಮಾಡೋಣ ಫಸ್ಟ್. ಓಕೆ, ಒಂದು ಫಿನೈಲ್ ಗ್ರೂಪ್ ಉಂಟು, ಅಯನೈಸೇಷನ್ ಆದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಪ್ಲಸ್ ಬರುತ್ತೆ. ಇದು ಬರೀ ಒಂದ್ ಕಡೆಯಿಂದ ಮಾತ್ರ ರೆಸೊನೆನ್ಸ್ ಇಂದ ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡುತ್ತೆ. ಇನ್ನೊಂದು ಸ್ಟ್ರಕ್ಚರ್ ಬಂದಾಗ ಏನಾಗುತ್ತೆ, ಅಫ್ಕೋರ್ಸ್ ಒಂದು ಫಿನೈಲ್ ಗ್ರೂಪ್ ಉಂಟು, ಅದು ರೆಸೊನೆನ್ಸ್ ಎಫೆಕ್ಟ್ ಇಂದ ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡುತ್ತೆ. ಅದ್ರ ಜೊತೆ ಏನುಂಟು, ಇನ್ನೊಂದೊಂದು ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಕೂಡ ಉಂಟು, ಅದು ಕೂಡ ಏನ್ ಮಾಡುತ್ತೆ, ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡುತ್ತೆ ಅತಿ ಬೇಗ. ಸೊ ಅತಿ ವೇಗವಾಗಿ ಮಾಡ್ತಾ ಅಂದ್ರೆ ಪ್ರಾಡಕ್ಟ್ ಏನಾಗುತ್ತೆ, ಬೇಗ ಸಿಗುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಯಾವ್ದು ಬರ್ಬೇಕೀಗ, ಎಸ್, ಒಂದು ಫಿನೈಲ್ ಗ್ರೂಪ್ ಇರೋದು, ಆಮೇಲೆ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಇರೋ ಕಂಪೌಂಡ್ ಬರಬೇಕು, CH3Cl. ಸೊ ದ ಲೀಸ್ಟ್ ವಿಲ್ ಬಿ ಯೋರ್ C6H5CH2Cl. Is that clear, guys? So these are the part which will be asking in your competitive exams. Okay, not in your normal board exam. But first important thing before solving this, what we require to know is ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ದಿಸ್ SN1 ಮೆಕ್ಯಾನಿಸಮ್ ಅಲ್ವಾ? ಸೊ ಮೆಕ್ಯಾನಿಸಮ್ ಅನ್ನಂದ್ರೆ ತುಂಬಾನೇ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ SN1 ಮೆಕ್ಯಾನಿಸಮ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಆಗ್ತಾ ಇರೋದು ಯಾವುದು? ಫಾರ್ಮೇಶನ್ ಆಫ್ ದಿ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್, ವಿಚ್ ಇಸ್ ದ ಸ್ಲೋಯೆಸ್ಟ್ ಸ್ಟೆಪ್, ಅಂಡ್ ಆಲ್ಸೋ ಇಟ್ ವಿಲ್ ಬಿ ಅನ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್, ಅಂಡ್ ದೆನ್ ವಿಲ್ ಬಿ ಯೋರ್ ಅಟ್ಯಾಕ್ ಆಫ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್. ಕಮಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಇಸ್ ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಟಿವಿಟಿ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ನಾವು ಹೇಳಿದ್ವಿ ಏನಂತ, ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ಸ್ ಆರ್ ಮೋರ್ ಸ್ಟೇಬಲ್, and also the tertiary alkyl halides will be having the higher order of reactivity. Why? Because it mainly depends what type of an intermediate it is giving you. So it is giving what? Tertiary carbocation. ಇಲ್ಲಿ ನಾವು ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ ಅಂತ ಯಾಕೆ ತುಂಬಾನೇ ಫೋರ್ಸ್ ಮಾಡಿದ್ವಿ ಅಂತ, ಸ್ಟ್ರೆಸ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ, ಬಿಕಾಸ್ ನಾವು ಕಂಪೇರ್ ಮಾಡ್ತಿರೋದು ಇಲ್ಲಿ ಬರೀ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ಸ್ ಮಾತ್ರ. ಅದಕ್ಕೆ ನಾ ಏನಂತ ಹೇಳಿದ್ರೆ ಟರ್ಷರಿ ಇಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್, ಅದಕ್ಕೆ ಅದು ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಟಿವಿಟಿ ಜಾಸ್ತಿ. ಆದ್ರೆ ಇಲ್ಲಿಗೆ ಬಂದಾಗ ಏನಾಯ್ತು, ಬೆನ್ಸಿಲಿಕ್ ಮತ್ತೆ ಅಲಿಲಿಕ್ ಕೂಡ SN1 ಮೆಕ್ಯಾನಿಸಮ್ ಅಲ್ಲಿ ಹೋಗ್ತವೆ ಅಂತ ಗೊತ್ತಾಯ್ತು ನಂಗೆ. ದೋ ದೇ ಆರ್ ಪ್ರೈಮರಿ ಅಲ್ವಾ, ಬೆನ್ಸಿಲಿಕ್ ಅಂಡ್ ಯುವರ್ ಅಲಿಲಿಕ್ ಆಲ್ಕಿಲ್ ಹಲೈಡ್ಸ್ ಆರ್ ಪ್ರೈಮರಿ, ಬಟ್ ಆಲ್ಸೋ ವಾಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್, ದೇ ಆರ್ ಅಂಡರ್ಗೋಯಿಂಗ್ SN1 mechanism itself, because whatever the carbocation they will be forming, it will be what? Resonance stabilized. ಅದು ನಮ್ಗೆ ಇನ್ನೂ ಡೀಟೇಲ್ ಆಗಿ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಯಾವಾಗ ನಾ SN2 ಹೇಳ್ತೀನಲ್ಲ, ಅವಾಗ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ವೈ ಐ ಆಮ್ ಸೇಯಿಂಗ್ ಸೋ ಅಂತ. ಆದ್ರೆ ಈಗ ಜಸ್ಟ್ ಯು ರಿಮೆಂಬರ್, ಅಲಿಲಿಕ್ ಮತ್ತೆ ಬೆನ್ಸಿಲಿಕ್ ಏನಾಗ್ತಾ ಉಂಟು, ದೇ ಆಲ್ಸೋ ಆರ್ ಫಾಲೋಯಿಂಗ್ ಯೋರ್ ರೆಸ್ಪೆಕ್ಟಿವ್ SN1 ಮೆಕ್ಯಾನಿಸಮ್. ಟ್ರೂ. ಸೊ ಆ SN1 ಮೆಕ್ಯಾನಿಸಮ್ ಅಲ್ಲಿ ನಾನು ಏನಂತ ನೋಡಿದೆ, ನಿಮ್ಮ ಅಲಿಲಿಕ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಅದು ಸ್ಟ್ರಕ್ಚರ್ಸ್, ಅಲಿಲಿಕ್ ಮತ್ತೆ ಬೆನ್ಸಿಲಿಕ್ ಅದು ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಮೇಲೆ ಏನಂತ ಗೊತ್ತಾಗ್ತಾ ಉಂಟು, ದೇ ಬೋತ್ ಆರ್ ಬಿಕಮಿಂಗ್ ರೆಸೊನೆನ್ಸ್ ಸ್ಟೆಬಿಲೈಸ್. ಸೊ ವಿ ಟಾಕ್ಡ್ ಓವರ್ ದೇರ್ ಅಬೌಟ್ ಡಿಫರೆಂಟ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್, ಅಂಡ್ ವಿ ಕೇಮ್ ಟು ನೋ as what, whenever there will be a more number of the phenyl groups, yeah, so what will be happening to the stability of the carbocation? It will be somewhat more stable. So along with the phenyl group, you are also having a methyl group. ಏನಾಗುತ್ತೆ, electron donating groups increase ಆಗ್ತಾ ಉಂಟು. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಆ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ ಇನ್ನಷ್ಟು ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ. ಸೊ ಅತಿ ಬೇಗವಾಗಿ ನಮಗೆ ನಮ್ಮ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ. ಸೊ ಆ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನ ಇಟ್ಕೊಂಡು ವಿ ಆರ್ ಸ್ಟಡಿಂಗ್ ದೇರ್ ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಟಿವಿಟಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಟ್ ಆಫ್ ಯೋರ್ SN1 mechanism. Is that clear? Okay. Coming to the concept of now one more SN1 mechanisms concept, that is called as stereochemical aspect. Stereochemical aspect of SN1 mechanism. ಏನಿದು ಅರ್ಥ ಅಂದ್ರೆ, what type of the products you can get. Okay, what type of the products you can get. Remember guys, before dealing with this part, I would just like to notify some important thing of your organic compound. For example, if I am going to write as a butane 2-all, okay, I'm not talking about the stereochemical. Important hints so that it should be easy for you when you're dealing with the further organic chemistry classes or preparing for your competitive exams. So when I'm writing as a butane 2-all, how can I write? Of course, I know the formula is in this way: CH3, CHOH, CH2, CH3. ಇದನ್ನ ಬಾಂಡ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗಿ ಬರೀಬೇಕು ಅಂದಾಗ ಏನ್ ಬರೀತೀನಿ ನಾನು, ಐ ವಿಲ್ ಬಿ ಚೂಸಿಂಗ್ ಅ ಕಾರ್ಬನ್. ಯಾವ ಕಾರ್ಬನ್ ನ ಚೂಸ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ, ಅ ಕಾರ್ಬನ್ ವಿಚ್ ಇಸ್ ಬಾಂಡೆಡ್ ಟು 4 other different groups. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಯಾವ ಕಾರ್ಬನ್ ನಾನು ಮಿಡಲ್ ಕಾರ್ಬನ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ, ದ ಕಾರ್ಬನ್ ವಿಚ್ ಇಸ್ ಅಟ್ಯಾಚ್ ದಿ 4 different groups. ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಲೆಸನ್ ಮಾಡೋತ್ತಿಗೆ ನಾವೊಂದು ಯೂಸ್ ಮಾಡಿದೆ, ಏನಂತ, ಕೈರಾಲ್ ಕಾರ್ಬನ್ ಅಂತ. ಕೈರಾಲ್ ಕಾರ್ಬನ್ ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ವಿಚ್ ಇಸ್ ಹೈಲಿ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್. ಏನದು ಅರ್ಥ, ಕಾರ್ಬನ್ ವಿಚ್ ವಿಲ್ ಬಿ ಬಾಂಡೆಡ್ ಟು ದಿ 4 other groups ಅಲ್ವಾ. ದಟ್ ಈಸ್ ಈ ಕಾರ್ಬನ್ ನ ಸೆಲೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಏನಾಗಿರುತ್ತೆ, H ಆಗಿರುತ್ತೆ. ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಏನಾಗಿರುತ್ತೆ, OH ಆಗಿರುತ್ತೆ. ಥರ್ಡ್ ಗ್ರೂಪ್ ಏನಾಗಿರುತ್ತೆ, CH3 ಆಗಿರುತ್ತೆ. ಫೋರ್ತ್ ಗ್ರೂಪ್ ಏನಾಗಿರುತ್ತೆ, ಈಥೈಲ್ ಗ್ರೂಪ್ ಆಗಿರುತ್ತೆ ಅಲ್ವಾ. CH2 CH3 ಅಂದ್ರೆ C2H5 ಅಂತ. ಸೊ ದಿಸ್ ಕಾರ್ಬನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್, ಆಸ್ ಅ ಕೈರಾಲ್ ಕಾರ್ಬನ್, ಆರ್ ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಸ್ಟೀರಿಯೋ ಸೆಂಟರ್. ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು, ಸ್ಟೀರಿಯೋ ಸೆಂಟರ್. ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ದಿಸ್ ಇಸ್ ವೆನ್ ಐ ಆಮ್ ರೈಟಿಂಗ್ ಫಾರ್ ಅ ನಾರ್ಮಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್. 2D ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಅಂತ, 2D ಅಂತಾನು ಹೇಳಕ್ ಬರಲ್ಲ, ನಾರ್ಮಲ್ ಆಗಿ ನಾನು ಬರಿಬೇಕು ಅಂದ್ರೆ ಈ ತರ ಬರಿತೀನಿ, ಎಲ್ಲದಕ್ಕೂ ಒಂದೇ ರೀತಿ ಬಾಂಡ್ ಬರ್ಕೊಂಡು. ಆದ್ರೆ ನಾನು ಈ ಒಂದು ಕಂಪೌಂಡ್ ನ ನೋಡ್ತೀನಲ್ವಾ, ವೆನ್ ಐ ಆಮ್ ಸೀಯಿಂಗ್ ದಿಸ್ ಕಂಪೌಂಡ್ ಥ್ರೂ ಮೈ ಅಲ್ಟ್ರಾ ಮೈಕ್ರೋಸ್ಕೋಪ್ಸ್. ಸೊ ವೆನ್ ಐ ವಾಂಟ್ ಟು ರೈಟ್ ಇಟ್ಸ್ 3D representation, I make use of certain notations for the bond. Once again, I'm repeating to you. So when I want to write this structure in a 3D representation, in a 3 dimension, your X, Y and Z, I use an important bond notations. Yav tara bond anna first ನಾನು ನಿಮಗೆ explain ಮಾಡ್ಬಿಡ್ತೀನಿ. I will be using a straight line, okay, continuous line. ಈ ಒಂದು ಲೈನ್ ಅರ್ಥ ಏನು ಅಂದ್ರೆ, ಇದು when I am writing this one as a bond, remember, this means it is in the plane of paper. What it is? It is on the plane of paper. Okay. So another line I'm going to write, which is like this, stake lines, and in which we are having in between the cuts. So they are called as staked lines. This means what? It is away from you or away from your observer. Away from observer. And another notation I'm going to write within a bond, which is called as a wedge. Wedge anta it is W-E-D-G-E. This means what? It is towards the or towards observer. Towards observer. In simple words, if I consider this sheet of paper is a plane, alva idu ಒಂದು plane ಅಂತ consider ಮಾಡೋಣ. ಇದ್ರ ಮೇಲೆ ನಾನು ಏನೇ ಬಾಂಡ್ ಬರೆದ್ರು it will be a continuous line. When I am going back side of this plane, alva ಈ ಒಂದು ಬುಕ್ಕಿನ ಬ್ಯಾಕ್ ಸೈಡ್ ಹೋಗ್ತೀನಿ like this. If it is coming in the back side, when it is coming in like this back side, so that will be represented as what? Away from alva. ನಮ್ಮಿಂದ ಹಿಂಗಡೆ ಹೋಗ್ತಾನೆ. ಅದನ್ನ ನಾನು ಯಾವ ತರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀನಿ? ಈ ತರ ಡಾಟೆಡ್ ಲೈನ್ಸ್ ಇಂದ. When it is coming towards the observer, in like this it is coming towards. ಇದು ಒಂದು ಪ್ಲೇನ್ ಅಂತ ಕನ್ಸಿಡರ್ towards coming. ಮೇಲ್ ಬರ್ತಾ ಉಂಟು. That will be represented by this wedge line. So when I am choosing this butane 2-ol, when I'm trying to write its 3D representation, how will I write it? You just see. So basically I'm going to write it in this way. CH2, CH3, H. You can just see that my ethyl group and my hydrogen group are in the plane or on the plane. On the plane. Next what is we can see? In ಎರಡು ಗ್ರೂಪ್ ಉಳಿದಿದೆ. ಯಾವುದು? ಒಂದು OH ಗ್ರೂಪ್ ಉಳಿದಿದೆ, ಇನ್ನೊಂದು CH3 ಗ್ರೂಪ್ ಉಳಿದಿದೆ. ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ ಈಗ OH ಗ್ರೂಪ್, it will be in this way. OH, and here you are having your CH3 group. So this is the actual structure of your butane 2-ol. ಏನು ಹೇಳುತ್ತೆ? The ethyl group and your hydrogen group are on the plane of paper, whereas your methyl group is away from the observer, whereas that of your hydroxide is towards the observer. Okay, this is just for a representation purpose we use. Don't get confused. Just for having a better knowledge, since we are learning somewhat thing, we should know each and every possible things, which can be easy for our next explanation. So ಈ ಒಂದು representation ಇಂದ ನಾನು ಏನು ಹೇಳಕ್ಕೆ ಇಷ್ಟಪಡ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ, whenever we are writing a continuous line, it is representing the bond, which is indicating that whatever the groups you have written, it is on the plane itself. If when you are writing the staked lines that or dotted lines, it is indicating what? That group is away from the observer. When I am writing this OH group over here to this wedge line, that means what? It is towards the observer. ಇದು ನಿಮಗೆ ತುಂಬಾನೇ ಯೂಸ್ಫುಲ್. ಈ ಸ್ಟ್ರಕ್ಚರ್ಸ್, ಈ ಬಾಂಡ್ ಗಳನ್ನ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳೋದು, ಪ್ರತಿ ಒಂದು ಬಾಂಡಿನ ಅರ್ಥ ಏನು ಅನ್ನೋದನ್ನ ತುಂಬಾನೇ ಮುಖ್ಯ ಆಗಿರುತ್ತೆ. So now keeping this one in mind, now let us see the stereochemical aspect of our SN1 mechanism. ನಿಮ್ಮ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಅವ್ರು ಹೇಳಿದ್ದಾರೆ ಏನಂತ? ಟು ಸ್ಟಡಿ 2-bromobutane. ಏನ್ ಹೇಳಿದ್ದಾರೆ? ಟು ಸ್ಟಡಿ 2-bromobutane ಬಗ್ಗೆ ಹೇಳಕ್ ಹೇಳಿದ್ದಾರೆ. ಏನಾಗುತ್ತೆ when you are treating this one with your aqueous KOH? ಯಾವ ತರ ಪ್ರಾಡಕ್ಟ್ ಗಳು ಸಿಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು ಅನಾಲಿಸಿಸ್ ಮಾಡ್ಬೇಕಂತ. Okay, do remember, very much important concept. So what I want to say over here is, remember guys, so whenever we are talking about your carbocation, any carbocation, you should remember that it is sp2 hybridized. And the carbon which has been attached to the 4 different groups, it will be called as what? As a stereo center. Okay, and you remember that whenever we are following your SN1 mechanism, and if the halogen is present on the stereo center, that is SN1 ಮೆಕ್ಯಾನಿಸಮ್ ಮಾಡೋತ್ತಿಗೆ ನಮ್ಮ ಒಂದು ಹ್ಯಾಲೋಜನ್ ಬ್ರೋಮಿನೋ ಕ್ಲೋರಿನೋ ಅಯೋಡಿನೋ ಏನಾಗಿರುತ್ತೆ ಆ ತರ ಒಂದು ಸ್ಟೀರಿಯೋ ಸೆಂಟರ್ ಕಾರ್ಬನ್ ಮೇಲೆ ಉಪಸ್ಥಿತವಾಗಿದ್ರೆ ಇಟ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಆನ್ ಸಚ್ ಸ್ಟೀರಿಯೋ ಸೆಂಟರ್ ಕಾರ್ಬನ್ ಏನಾಗಿರುತ್ತೆ ಯೋರ್ ಪ್ರಾಡಕ್ಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ ಯು ಅ ರೆಸಿಮಿಕ್ ಮಿಕ್ಸ್ಚರ್. ಏನ್ ಹೇಳ್ತಾ ಉಂಟು ಯೋರ್ ಪ್ರಾಡಕ್ಟ್ ವಿಲ್ ಬಿ ಗಿವಿಂಗ್ ಯು ಅ ರೆಸಿಮಿಕ್ ಮಿಕ್ಸ್ಚರ್. ಯಾಕೆ ನಾ ಇದನ್ನ ಮೊದಲೇ ಹೇಳ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ ಬಿಕಾಸ್ ವಿ ಹ್ಯಾವ್ ಕವರ್ಡ್ ದಿಸ್ ಟರ್ಮ್ಸ್ ಇನ್ ಅವರ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಲೆಸನ್ಸ್ ಇಫ್ ಯು ರಿಮೆಂಬರ್. What do you mean by racemic mixture? What do you mean by racemization? If you want, you can just have a look on those topics once again. So what they are saying, remember, in an SN1 mechanism, if the halogen group is attached to the stereo center carbon, product will be a racemic mixture. Racemic mixture ಅಂದ್ರೆ ಅರ್ಥ ಏನು? Yes, racemic mixture andre you will be having the product as 50% as a D form and 50% as an L form alva. Plain polarized light na right kade tirsidre clockwise agi tirsidre adu nav ಏನಂತ ಹೇಳ್ತೀವಿ ಆ ಫಾರ್ಮ್ ನ D form dextro rotatory. ಅದೇ ರೀತಿ ಲೆಫ್ಟ್ ಕಡೆ ತಿರ್ಸಿದ್ರೆ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್ ಲೈಟ್ ನ ಅದನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು levorotatory alva. So depending upon this aspect, that when you are having such two forms in 50% and 50% ಅವಾಗ ಏನಾಗುತ್ತೆ ಆ ಪೋಲರೈಸ್ ಲೈಟ್ ನ ರೊಟೇಟೇ ಮಾಡಲ್ಲ. ಸೊ ಆ ಒಂದು ಮಿಕ್ಸ್ಚರ್ ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ ರೆಸಿಮಿಕ್ ಮಿಕ್ಸ್ಚರ್. ಈ ಒಂದು ರೆಸಿಮಿಕ್ ಮಿಕ್ಸ್ಚರ್ ನಮ್ಗೆ ಯಾವಾಗ ಸಿಗುತ್ತೆ whenever the stereocenter carbon which has been attached to that of your halogen group follows an SN1 mechanism, product whatever it is going to give will be a racemic mixture. Very much important. So now let us just deal with it. 2-bromobutane. So how the structure will be CH3, yes, Br. Here you will be having your C2H5 and here you are having our H alva. This is now a stereo center. ಇದೇನಾಗಿರುತ್ತೆ ಈಗ stereo center which has been attached to that of your halogen. So ಇದನ್ನ ನಾನು ಯಾವಾಗ when 2-bromobutane is heated in the presence of your aqueous sodium hydroxide ಇದೇನ್ ಕೊಡುತ್ತೆ ಅನ್ನೋದನ್ನ ನೋಡೋಣ. ರಿಮೆಂಬರ್ ಗೈಸ್ ಏನಾಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಬೇಸಿಕಲಿ ಇದೀಗ Br ಹೊರಗೋಗಿ ನಮಗೆ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಅಂತ ಕೊಡ್ಲೇಬೇಕಲ್ವಾ. ಏನ್ ಕೊಡುತ್ತೆ ಅವಾಗ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಅಯೋನೈಸೇಷನ್ ಆಗುತ್ತೆ. CH3 ಇಲ್ಲಿ H ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನಾಗಿರುತ್ತೆ C2H5 ಇಲ್ಲಿ ಪ್ಲಸ್. ಸೊ ಯು ಗಾಟ್ ಎ ಕಾರ್ಬೋಕ್ಯಾಟಯನ್. ಸೊ ಈ ಒಂದು ಕಾರ್ಬೋಕ್ಯಾಟನ್ ತಗೊಂಡಾಗ ಜಸ್ಟ್ ಐ ವಿಲ್ ರೈಟ್ ಹಿಯರ್ ಇಟ್ ಸೆಲ್ಫ್. ನೋ ಯು ವಿಲ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್. ಲೆಟ್ ಮಿ ರೈಟ್ ಒನ್ ಸೆಕೆಂಡ್. CH3 H and over here I am getting as what? C2H5. Okay, and I am having it as a plus. So now when there is an attack of a nucleophile for such a carbocation, do remember there are two possibilities. There are two possibilities. What possibilities are those? This OH can attack this carbon in two ways. What is that? One, whatever your hydroxide group is there, this hydroxide group can come and attack the carbon either from above the plane or that of your below the plane. Two possibilities are there. Let me write both the possibilities. So ಯಾವ ತರ ಹೇಳ್ತಾರೆ ಅನ್ನೋದನ್ನ ನೋಡ್ಕೊಬಿಡೋಣ ಫಸ್ಟ್. ಸೊ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ CH3 ಇಲ್ಲಿಂದ ಅಟ್ಯಾಕ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಸಾರಿ, your OH and over here as your C2H5 and over here as H. This is one possibility, and the another possibility is how CH3 C2H5H, and over here you can see another which is your OH. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಸೊ ಒಂದಲ್ಲಿ ಏನಾಗಿದೆ, ಇಟ್ ಕ್ಯಾನ್ ಕಮ್ ಆಸ್ ಫ್ರಮ್ ದಿ ಅಬೌವ್ ದಿ ಪ್ಲೇನ್ ಇಂದ ಅಟ್ಯಾಕ್ ಆಗಿದೆ. ನೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ, ಕೆಳಗಡೆ ಪ್ಲೇನ್ ಇದೆ. ಸೊ 2 ಪಾಸಿಬಲ್ ಪ್ರೊಡಕ್ಟ್ಸ್ ಆರ್ ಆಲ್ಸೋ ಅವೈಲೇಬಲ್ ಫಾರ್ ಅಸ್. ಎಷ್ಟು ಪಾಸಿಬಿಲಿಟಿ ಇರುತ್ತೋ ಅಂತ ಗೊತ್ತಿಲ್ಲ, ಅಷ್ಟು ಪಾಸಿಬಿಲಿಟಿ ಪ್ರಾಡಕ್ಟ್ಸ್ ನಮಗೆ ಬರಕ್ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಬಟ್ ವೆನ್ ವಿ ಆರ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ದಿ 2-bromobutane, what is happening? It is undergoing an SN1 mechanism, and also moreover the halogen group is attached to that of your ಸ್ಟೀರಿಯೋ ಸೆಂಟರ್. ಇದು ತುಂಬಾನೇ ಇಂಪಾರ್ಟೆಂಟ್. ಸ್ಟೀರಿಯೋ ಸೆಂಟರ್ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಹೈಲಿ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್, ಕೈರಾಲ್ ಕಾರ್ಬನ್. ಯಾವಾಗ ಈ ತರ ಒಂದು ಕಾರ್ಬನ್ ಮೇಲೆ ನಿಮ್ಮ ಹ್ಯಾಲೋಜನ್ ಇರುತ್ತೋ ಅದಕ್ಕೆ ಬಂದು ನಿಮ್ಮ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಯಾವತ್ತೇ ಬಂದು, ಇನ್ ಎನಿ ಕೇಸ್ a nucleophile is coming and attacking, you are getting a 2 types of a product. One will be your L isomer and another will be your D isomer. So how can you say the product name? So one will be your L-butane 2-all and another will be your D-butane 2-all. So our reason in the name heltivi, it will be giving you a racemic mixture. Very much important aspect one has to keep in your mind. So this part is also there in your syllabus, so that is the reason. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ ಏನಂತ ಹೇಳ್ತಿದ್ದೀನಿ? ಯಾವತ್ತೇ ಒಂದು SN1 ಮೆಕ್ಯಾನಿಸಮ್ ಅಲ್ಲಿ ಒಂದು ಸ್ಟೀರಿಯೋ ಸೆಂಟರ್ ಕಾರ್ಬನ್ ಇದ್ದಿ ಅದಕ್ಕೆ ನಮ್ಮ ಹ್ಯಾಲೋಜನ್ ಅಟ್ಯಾಕ್ ಆಗಿದ್ರೆ ಅಥವಾ ಅಟ್ಯಾಚ್ ಆಗಿದ್ರೆ, and it is undergoing an SN1 mechanism, you will be getting a 2 types of the product, and that is also a racemic mixture. Very much important aspect to remember. Next, we are going to see the another mechanism which is called as SN2 mechanism.